Hello everyone, welcome to another lecture on the topic of reciprocal of a linear function. What we have here is the function f of x equals 1 over mx plus b, and that is obviously the reciprocal of a linear function because in the denominator you see mx plus b, that's a linear function itself, and the restriction on the domain of a reciprocal linear function can be determined by finding the value of x that makes the denominator equal to 0. So here, if you set mx plus b equal to 0, you would end up with x equals negative b over m. And that would be the non-permissible value of the reciprocal function. For the graph of the rational function, that value, where the function is undefined, will play the role of the vertical asymptote, which is a vertical line, in this case x equals 0, and this vertical line is a line that the graph approaches but never touches it. The vertical asymptote of a reciprocal linear function has the equation of the form y equals negative b over m, not y, x equals negative b over m. And we have mentioned how we find it by setting the denominator equal to 0 and solving for x. Now here, b is equal to 0, m is equal to 1. So basically we have 1 over x, which is the basic reciprocal function or the parent function. And we're going to see what happens if I change the value of b right now here. So if we change the value of b, we see that the graph starts horizontally shifting to the right and left, as you can see here. And as it shifts to the right or left, the vertical asymptote also translates with the graph. It's sort of attached to the graph. So I'm going to keep b to be 1, for example. And now we're going to see the effect of changing m. When we change m, we see that the graph is horizontally shrinking or horizontally being compressed, basically, when the value of m is, of course, greater than 1. So that's the effect of m. If m is greater than 1, we have a horizontal shrink or compression by a factor of 1 over m. And whenever m is less than 1, such as 1/2, 1/3, 1/4, but still positive, then we have a horizontal stretch or expansion by a factor of 1 over m. So that's the role of m and b in terms of transformations. And the horizontal asymptote of a reciprocal linear function has the equation of y equals 0, which is actually the x-axis. So I can here define y equals 0, which is the horizontal asymptote. It's this blue line you see, and it does not change because of an obvious reason, because the degree of the numerator is always 0, degree of the denominator is always 1, and whenever the degree of the top is less than the degree of the bottom, then we have y equals 0 as the x-axis, playing the role of the horizontal asymptote for not only this rational function, but for any rational function, in fact. Now, if the value of m is positive, like 4.5 here, or like 3.5 or whatever, the left branch of this reciprocal linear function has a negative decreasing slope, and the right branch has a negative increasing slope. Now, what does that mean? I'm going to explain. So let's have a look at this left branch of the function. And let's draw some tangent lines at, let's say, a point with an x-coordinate of negative 2.3 or negative 2, let's say. Okay, at x equals negative 2, we are drawing a tangent line. Now, as you see, this tangent line on the left side branch is a tangent line that is falling from left to right with a negative slope. And by the way, tangent line is a line that intersects a curve at only one single point, known as point of tangency. It's shown here with this blue dot here. So this tangent line has a negative slope. That's what we're saying on the left side branch of the graph, and it has a decreasing slope because you see that as we move from left to right, the slope is decreasing. Okay, from left to right, let me show it again. From left to right, the slope of the line is decreasing. Okay, and on the right side branch, whenever let's say a is like a positive number, let's say it is, let's say 0.37. Okay, here on the right branch, the graph has a negative slope again, but this time increasing slope, meaning that from left to right, um, the slope of this tangent line increases, as you clearly see in the diagram. So this description was for when m is positive. Okay. Now, what happens if m is negative? So I'm going to select a negative value, let's say negative 5, and I'll go up to 0 so that I exclude the positive values. And let's see what happens to the graph. So you see this time uh, when the value of m is less than 0, that is negative, the left branch of this reciprocal function has a positive increasing slope. So you see that this line is rising from left to right, so obviously it has a positive slope. But as you see, when we move from left to right, it has an increasing slope. And the right branch instead, here, again, of course, it has a positive slope, but positive decreasing slope, because as we move from left to right, the slope is decreasing. Let me show it to you one more time. So I'm moving from left to right slowly. As you see, the slope is decreasing. Now, just to show what is like going on in terms of the shape of the graph for different values of m and b, let's change both of these factors and see what is happening here. I can, of course, get rid of the equation of the tangent line and the point of tangency, and then you can only see the graph of the reciprocal function and see how it changes. Of course, m here, I have to change the value from negative 5 to positive 5 so that I can have both values of m, positive and negative. And as you see, for example, right here, so here, when you see that the value of m is a positive number, you see that the left side branch is below the x-axis, but when m is like negative, you see that the left side branch is above the x-axis. So that's the major difference here. Okay, so I hope you understood how uh, how a reciprocal function may change if the values of m and b in the denominator change. Thank you.